Welcome to Module 2. In this module, we'll be discussing soil sampling and fertilizer calculations. We'll go over climate, the hydrologic cycle, which ultimately brings us to how we get water and then how that water interacts within the soil. All right, so kind of the whole purpose of taking a soil sample, first off, we kind of need to know what is there before we start applying fertilizer, just to know if we even need to apply fertilizer. And if we don't have the proper fertilizer, the proper fertility, well, then this is going to allow us to predict the probability of a profitable response to that lime or fertilizer. And then finally, within that soil sample, they'll give us lime and fertilizer recommendations that are going to help us optimize our crop yield. So a few things we want to consider when we're talking about soil analysis and soil sampling is that soil is variable. It's not consistent throughout an entire field. So not only horizontally or, the area, but also within depths, it's going to vary as well, because remember that soil forms over time and there are different layers, and sometimes that soil can erode and move from a place of higher elevation to lower elevation, and that's going to change some things as far as the soil consistency. Next, because of that, we want to take composite samples that are really representative of a sample area. And so if you watch the web soil survey video, you'll see that, there are different soil series within that field. And we don't want to take a soil sample, one sample for that whole field if we know there are different soil types. Now we could probably take the same soil series or a different area that may be managed differently, but we wouldn't want to take one soil sample for that whole pasture. When we take our soil samples, typically those will be taken from a depth of about 6 to 12 inches. We use 6 inches because that's kind of our plower layer. If it were pasture, it would probably be a little bit less, as we'll see on the next slide. But typically you're going to take a soil sample from a depth of about 6 to 12 inches. Another important thing to consider is the time of year that you're taking that. So if you are really trying to be efficient with your crop production and you really want to know how much you actually applied, how much you actually used, what is left over, the time of year is when you're going to want to consider your sampling process. And so typically pre-plant, we would want to take that about 2 or 3 weeks, maybe even a month before we're about to plant. So when I think about taking soil samples before we're about to plant a crop, I'm thinking maybe corn or soybean. We know that we want to get those soil samples back, and if we need to apply any fertilizer or lime, we want to have about 2 to 3 weeks, maybe even 4, for that fertilizer to be applied, undergo the transformations that it needs to go in order to be available for the plant. So not only do we take our soil samples pre-plant, that lets us know kind of what's in the soil before we start, and then we know that we applied a certain amount of fertilizer. And then if we take soil samples post-harvest, then we know how much fertilizer or of those how much of those nutrients that the plants actually took up, and then we can start to calculate nutrient use efficiency. And then also kind of post-harvest is going to allow us, maybe if we're growing a cover crop, we'll kind of also know if there are any nutrients that we need to apply to make sure that our cover crop is going to be successful as well. So kind of when we talk about where to sample and our sampling depth, you can see the different depths for the different types of crops that you're growing. Pasture or lawn, somewhere between, I'm going to guess about 2 inches is going to be fine, because you have to think about that our root system in a pasture or in a lawn is not going to be very deep. So we're really going to apply those nutrients and make sure that they're in the root zone is really where we want to put that. For just a regular crop, we're going to look at 4 to 6 inches because our roots are only going to go about 6 inches deep, maybe 8. But if we had a perennial crop that is continually growing, those roots are continuing to grow down in the soil, And so we want to make sure that we're getting nutrients down to that depth as well. There are a few considerations for where you're sampling. Typically, we'll want to sample in a random zigzag pattern, just so that we're not taking one sample straight across this field, because we're going to get a composite sample of this field, right? And so, we're not going to be perfectly accurate with everything that we put on this land, but we are at least going to make sure that we bring our soil nutrient levels up to sufficient. A couple of things that we want to avoid are going to be trees. And one of the reasons that we want to avoid trees is because if you've ever sat underneath an oak tree, that ground is very hard. And there is not a lot of water movement through there because the trees have taken up most of those nutrients and that water. So that's going to kind of skew your soil sample. We want to stay away from hay rings or feeding areas, because while they're also ingesting the food, they are also releasing some of that waste back into the soil profile. And so you might have a spike in nitrogen around our hay area. We want to avoid like limestone roads or anywhere where there's like gravel, because that could actually change the pH. And so if we took a soil sample here and then added that into soil samples here, it's possible that because this is close to limestone, that the pH around that fence area might be greater than the pH that is maybe further into the field. So just a couple of thought processes as you're starting to take those soil samples. Next, we have different soil sampling methods. And so one of those is you're either going to do that as a grid system, where you are taking specific grids and basically making a map of your field and knowing that within the grid you took this random soil sampling pattern and made it into a composite, and that is the soil sample pattern for that is the soil sample, composite soil sample for this particular grid. Typically those are done on 2 to 2.5 acre grids. Or we have a zone system. And so, again, inside of each one of those zones, we're going to take that random soil sample pattern so that we can get a good composite sample, so that when we send that off, we know that if we're going to fertilize something, this might have more or less nutrient in this area. And we know that when we apply that fertilizer, we can adjust accordingly. Typically, this will be done in, as far as like how you manage your fields, and then also soil type. So soil series, if we had something like that, we would use a zone system to make sure that we're separating those and we're not getting invalid data. When we take these grid systems, if we were to use a grid system, there are a few ways we can do that. You can either take it at the center of that grid. So we have the grid center. You might hear this from Dr. Bear as a grid point. So you come and take it at the actual intersection of each of those 4 grids, and that kind of gives you another data point. Or you can really just take these random inside of that. But again, once you get to that place where you're going to sample, like let's say if you were doing this random location, once you got to that location, you're going to want to take 8 or 10 samples, 8 to 12 cores at that point, so that you can get a representative sample. Because if you just took one soil core, that's not really representative of that point. We would want to make sure that we have enough data to give us a good average. A couple of other different types of grids we can see. We have a uniform grid. We have offset, which, this one, if you had a large tract of land and you didn't want to, you didn't have the budget in order to take each one of these samples. So, this is going to be probably about 15 or 20 samples at, $20 a sample. That's $400. Now down here, we probably have about 10. And so now it's only $200. And so in the beginning, if you buy a piece of land and you want to get some quick data, it's probably best to do more of an offset grid in a larger area, just so that you can get some beginning information about what is going on in that soil and where you might need to address. These stratified, random, and this rectangular grid, you probably won't worry about too much, but these two you would probably use the most. All right, so how do we take this sample? And so we've already determined our field size and our pattern, whether we're going to use a grid or whether, and our zigzag. And so this picture here kind of shows a home lawn and having different cropping systems, so to speak, where they might take samples in the front lawn, the back lawn, and the trees and the shrubs, and then the vegetable garden. And when they send these in, they will get different recommendations for each one of these different areas instead of just a blanket application of fertilizer across all of them and possibly spend money where they didn't need to. So we're going to want to take these soil cores with a clean probe, and we want to remove this organic material and place that core into a clean plastic bucket. We don't want to use anything metal because we don't want to contaminate, potentially contaminate any of that soil material. If you were to use an aluminum bucket, you might change the pH in that, or maybe you have some elevated aluminum, which might skew your soil test results. We're going to place that mixed soil in a soil sampling bag with a label, and then we're going to fill out a lab sheet for that. And I'll make a specific video about how to fill that out. It's not very difficult, but just to kind of understand where those how you go about sending that off and what you can test for. So once you send your soil sample off, they're going to do a chemical analysis depending on what you tell them. You'll typically get a pH, your organic matter. It'll tell you what the cation exchange capacity is. And if you remember, the cation exchange capacity is kind of like that big cup, little cup. Next, we're going to have, just your basic macronutrients. Remember C. Hopkins Cafe, managed by my cousin Mokelnina. And if you wanted to, you could get micronutrients as well. All right, so once you send that off, you're going to get those reports back. Each lab has a different, layout or a different type or style of reporting that, but the data is going to be pretty much the same. You might just have to look for it in a different spot. And so here it's going to tell us that we have, our percent organic matter, how much phosphorus, potassium, magnesium, and calcium. And typically these will give you a range. I really like in the next slide, I really like getting them from like Waypoint or someone that gives me a bar graph, because I can really look simply and go, all right, my pH is I don't need to apply lime. I'm low in phosphorus and potassium. I don't need to worry about calcium, magnesium, and sulfur. Real quick, I don't need to focus on those things. So a bar, one of them with a bar graph is really good for being able to interpret that soil test report and go, okay, phosphorus and potassium are deficient. That's why my crops aren't growing. We're going to go over this again in Module 4 when we talk about 4R nutrient stewardship and fertilizer use efficiency. So over here we have our cation exchange capacity at a CEC of about 20.7. So this milliequivalents per 100 grams is the same thing as the centimoles of charge per kilogram that you've seen me use previously. So our CEC is about 20.7. This is probably going to be a medium-sized cup. I'm just have a couple of things to show you just in different places from different soil tests, might have different things, but notice that we have this medium, high, low, or very low. And we can see this back here as well. We have a rating of medium, very low, low, and high. I guess those are kind of relative to the area that you're they're kind of relative to the area that you're in, and also the crop that you add into that field to let them know, like sample ID for lawn. So for a lawn, we're plenty sufficient in magnesium, but we're a little lacking in phosphorus. Another thing that you won't, or it's not that you won't get it, you are not likely to get on a soil test report is nitrogen. They will not report that. They'll give you a recommendation for how much nitrogen you need to apply based upon your crop. Again, just showing you there are some different soil test reports. They're all kind of different, but they're all also kind of the same. We've still got, our pH. This one, we actually got nitrogen in this soil sample. And then it also gives you our C. Hopkins Cafe managed by Mine Cousin Mokel Nina. And they also asked for some micronutrients as well. Okay, so once you get this recommendation back, it is going to, you'll receive the recommendation. So the top dress is you want to apply 95 pounds of nitrogen per acre, or possibly 50 pounds of P2O5 and 110 pounds of K2O. This is the rate. Suggested fertilizer rate in pounds per acre. I just want you to remember that. And then on the bag of fertilizer, these numbers are N, P2O5, and K2O. Now you're likely going to hear people just say that the numbers on the bag are N, P, and K. That is technically not correct. Those values are nitrogen, P2O5, and K2O. Believe it or not, this is likely to be a question that they will ask you maybe at a job interview. I had a student who said they actually got a job because they knew what those values were, and that there were other applicants who didn't. But she also mentioned that it was the P2O5 and the K2O, and that was kind of the trigger that kind of let the employer know that she had been at least exposed to this information and understood what it meant. So for me, this is kind of like the fundamentals of soils and soil fertility. Like if you don't leave agriculture, there should be at least two things you need to know how to do when you leave soils and soil fertility in the School of Ag. You should know that there are 43,560 square feet in an acre. And you should be able to calculate how much fertilizer needs to go on that acre. So that is going to be rate over analysis. And you will hear me say that more often than you like to hear. So if we have a 50-pound bag, these values that are on the bag are represented as percentages. So there's 10% nitrogen, 10% P2O5, and 10% K2O. So how many pounds of nitrogen, P2O5, and K2O are in this 50-pound bag? (50 times 0.1 is 5. So there are 5 pounds of nitrogen, P2O5, and K2O in this 50-pound bag. So typically what will happen is, at least for the test that I'm going to give you, you'll be given a scenario, such as the one that you see here. You'll be given an area. You'll be given a rate and the analysis and likely the cost of that fertilizer. Because these are going to be the fundamental things that you need to know. If you're going to go manage a field somewhere, one of the things you will have to do as a manager is a fertilizer budget. So the thing we need to know is how much urea do I need and what is the total cost of that application. So the first thing we need to do is calculate how much fertilizer we need for 1 acre. And the way that we do that is we calculate rate over the analysis. And so the analysis will always be as a percentage. And typically I'll put that as a decimal. And generally it will, I take that back. The analysis will always go on the bottom when asked for how many pounds of fertilizer you need to apply. When asked how many pounds of fertilizer you need to apply, the analysis is on the bottom. Rate over analysis. And so this is a very simple division calculation. So we know that our rate is 100 pounds of N per acre. That was given to us right here. And our analysis is 4600, which means this is actually 46% nitrogen. So 100 divided by 0.46 equals 217.39 pounds of 4600 or 4600 per acre. Everyone following how I got that? And so if you think about it, this kind of makes sense because we would need a little more than twice as much fertilizer to apply this 100 pounds of N. Like notice that this is almost half, which would mean we would need twice as much fertilizer to meet this recommendation. All right, so once we know that we need about 217.4 pounds of 4600 per acre. Now, how much fertilizer do we need to cover 3.25 acres? So if we know we need 217.4 pounds for 1 acre, we would just multiply that times 3.25 acres. And when we do that math, we find that we need about 706.52 pounds for this 325 acre field. All right, next, how much is that going to cost us to fertilize that field? And so when I talk about price over product, typically the example that I'll give is like when I go to Walmart, I look to see what it costs per ounce. I look to see what it will cost per pound of, I don't know if it's cheese or if it's meat or whatever it is, right? So it's, chicken is like $2.99 a pound. So understanding that allows me to make the most economical decision for, what I'm getting. Like, I guess the best bang for your buck. So in order to understand that, we are going to use price over the product. So price over product, we have $880 per ton, and a ton is 2,000 pounds. And this is going to give me, look here, dollars per pound. So when I do this math, we get $0.44 per pound. Everyone seeing how we got that there? Very simple calculation. Basically, you're just dividing 880 divided by 2,000. And once you know how many pounds, what the cost is per pound, then you just multiply times the number of pounds that you need. So, in order to figure out how much it costs for this 3.25 acres, we know that we need 706.52 pounds of urea for 3.25 acres. And we know that it costs 44 cents a pound. So 706.52 times 44 gives us $310.87. That's what it will cost us to fertilize this field. Okay, so now that we've done the rate over analysis, one of the things I like to have students do is to understand that it might be that you get some credit if you use a fertilizer source that has more than one nutrient in it. And typically, students are, many ag students or, those who are raised on a farm are familiar with a fertilizer called DAP, diammonium phosphate. And DAP has a guaranteed analysis of 1846.0. So 18% is going to be nitrogen, 46% is going to be P2O5, and 0 K2O. So if you applied 100 pounds of fertilizer, let's just say you had 2 bags of DAP and you put it in the spreader and applied it over an acre or whatever area, it doesn't matter. In this particular instance, we're just applying 100 pounds of material. So now we're going to do the opposite. So if you've already applied the material, you're going to multiply. Already applied, multiply. If you are given a rate, you are going to do rate over analysis. So given the rate, you're going to divide. If you've already applied, you're going to multiply. And this is just to get students to understand that like you're going to actually get a nitrogen credit if you use, it could even be that you get a phosphorus credit by using this. So what we do is for our nitrogen, we know that we applied 100 pounds of 1846O, and 18% of that is nitrogen. So we're going to multiply that times 18% or 0.18, and that gives us 18 pounds of N. So when we do the P2O5, it's the same thing. Multiply 100 pounds times 46%, and we know that we applied 46 pounds of P2O5. So with this application, we actually kind of, got 18 pounds of nitrogen and 46 pounds of P2O5 for the same price as whatever this fertilizer costs. And so I believe that for the most part, this should get you through calculation 2. I'm going to make another video that kind of walks through a little bit about the table and how to go about calculating that overall budget. But this will at least get you through, working on the beginnings of calculation 2. Remember that you can take that calculation 2 as many times as you like and use that as practice. But there will be another video coming soon. All right. So that's going to end that for this soil sampling and fertilizer portion of this video.